This is lesson number 79 in Algebra 1, and it's called System of Equation with Subscripted Variables. Alright, so we use subscripted variables. I guess I should probably first of all tell you what a subscripted variable is. You're used to variables like that. Subscript is right here. Sub means under and script means writing. So we're putting a letter down there. And all these subscripted variables is it gives you a little bit of explanation. I mean, I could write that as just x, but I don't know what x is. But let's say that I'm looking at the rate of Andy and the rate of Ben. I could use x for the rate of Andy and y for the rate of Ben. Okay, two different letters. That's fine. But I get confused. Which one is Andy and which one is Ben? It's kind of a pain in the neck. But if I write RA and RB, this is the rate of Randy, that's the rate of Ben. That's all the double variables are. That's all a subscripted variable is just to give you a little clue about which one you're talking about. So this is actually just one variable with an explanation A of who we're talking about. So that being the case, let's go ahead and get started with our first example. Alright, we have R, A, T, A, so two letters multiplied, plus R, P, T, P equals 320. We don't have to even worry about what those mean. We know that RP is 50. We know that TP is 4, and we know that TA is 3. Okay, so we know that information. They want us to find RA. They want us to find what that is. So all we do is plug the information that we know in. We know that TA is 3, RP is 50, and TP is 4. And that equals 320. And then we just do the math. RA times 3 plus 200 equals 320. Subtract 200 from both sides, and we get RA3 equals 120. Divide by 3, divide by 3, and the rate of Andy or whoever is going to be 40. And we're done. Okay? So there's nothing really terribly scary about this. It's just understanding that subscripted variables just give you a little bit more information about what you're looking for. Let's look at the second example here. Given that, I'm told that RT is 2. I'm told that RR is 10. And that TT equals TR. Okay, well, let's go ahead and put the information that I know in here. And actually what we're looking for is TR and TT. Now they're both equal to each other. We just determined that in the instructions. So when I find one, I've got the other. But let's go ahead and put information in here. RT is 2 plus 120. RR is 10. And TR we don't know. Alright, since we know that they're both equal to each other, I can write the TR as a TT, and then I've just got the same variable, right? Since they're equal. Now I only have one variable. Alright, so I'm going to move this over here by subtracting it from both sides. Divide this by 8, divide that by 8, and I know that 8 goes into 120 15 times, so that's what my TT equals, which is also what my TR r equals since they're equal to each other. Okay, we'll look at a couple more examples and we'll be done. We've got RL, TL is equal to RSTS, okay, not 5. RL equals 40. RS equals 80. TS equals TL minus 5. And we're looking for TL and TS. Those are the two we're looking for. So let's take our original one up here and put what we know in there. Don't know what TL is. I know RS is 80. Okay. But what do I know about TS? It equals TL minus 5. So instead of a TS, I'm going to put that in there. Times. Don't forget to put them in brackets so you group them together. Now I have a TL and a TL. So therefore I have the same letter. Makes life so much easier. Distribute the 80. 80 times 5 is 400. And let's go ahead and move this over. Move this all up. Okay, in red, that gives me negative 40. Now remember, if you have a negative, you can change it to a positive if you change everything. Divided by 40, and TL equals 10. Alright, so sure, TL equals 10, but what else did they ask us to find? They also asked us to find, let's see, TS. And what did they say about TS? TS equals TL minus 5, or 10 minus 5, which equals 5. So TS equals 5. So we just plugged this into what they gave us and got that. Okay, one more example and we'll be done. Okay, so there's the information they give us for 79.4, and they want us to find RF and RE. So those are the two things we're looking at. There's our problem. We'll plug in what we know. So RF, we know TF is 16, and that equals RE, which we don't know, but we know TE is 12. And when we look at this, we see that RE is RF plus 15 times 12, and then we've got an RF here. And again, that by substituting there, we have the same variables, which means we can solve it. So I'm going to move the 16 in front, just because I'm used to having a number in front. And let's move this in front, distribute 12 RF. That doesn't look like an R, does it? Plus 12 times 15 is 180, I think. Okay, now we're going to subtract this from both sides. So 16 minus 12 is 4 RFs. Divided by 4. Divided by 4, so our RF equals 180. Divided by 4 is 45. Okay, so that's our RF. We're also looking for RE, and we know that RE equals whatever we got for RF plus 15. So 45 plus 15 is 60, so that's 45. And that's our answer to example 79.4. And that's it for problems or lesson number 79.